On August 10, 2025, at exactly 3:25 p.m., Russian commanders gathered inside an underground headquarters near Kherson. The location was a fortified command facility constructed with multiple subterranean galleries, designed to serve as a hardened node for operational planning on the southern front. 25 high-ranking officers, including battalion and staff commanders, had assembled for a scheduled briefing. At the surface, the site showed only communications antennas and routine service structures designed to conceal the true purpose below. Inside, the atmosphere was relaxed. Being underground and reinforced, the Russian officers believed they were secure. What they did not know was that this facility had already been compromised. For months, Ukrainian intelligence had tracked the rhythm of the site. Surveillance drones monitored antenna rotations, service doors, and the movement of vehicles and personnel. Electronic intercepts confirmed communication flows. Satellite imagery provided visual confirmation of entry and exit patterns. Signal analysis revealed when commanders typically convened. Piece by piece, the Ukrainian military had mapped not just the building, but the operational habits of the staff who relied on it. By early August, the patterns aligned clearly enough to predict a high-level meeting at that precise time. The intelligence was decisive. The Ukrainian Air Force was assigned to deliver a strike. But destroying an underground hardened facility is not straightforward. The structure was designed to absorb or deflect surface blasts. A conventional bomb would have limited effect. For this mission, a single F-16 Fighting Falcon would be armed with 2 GBU-62 Joint Direct Attack Munition Extended Range Bombs, commonly known as JDAM-ERs. Each carried a 454-kilogram penetrating warhead, equipped with delayed fuses. The design allowed the munition not just to explode on impact, but to detonate after penetrating into reinforced structures, collapsing underground galleries from within. The mission required meticulous planning. The F-16 would take off from a mobile, auxiliary runway at 1457. Operating from mobile bases allowed Ukrainian aircraft to avoid predictable patterns and limit exposure to Russian missile strikes on fixed airfields. Before takeoff, technicians armed the jet with the 2 JDAM-ERs on its wing stations. 2 AIM-120 air-to-air missiles remained on the wingtips for self-defense. The fuselage carried an ALR-56M threat warning receiver, an ALE-50 towed decoy system, and a chaff pod. Additional 370-gallon external tanks extended range and safety margins. Software preparations were equally detailed. GPS and inertial navigation profiles for the JDAMs were uploaded, along with toss swing parameters required for extended range release. The pilot was briefed to remain at extremely low altitude, 50 to 60 meters above ground level, using terrain masking to remain below Russian radar coverage. At such low altitude, the curvature of the Earth limits radar detection. Even powerful long-range radars like the S-300 or S-400 systems cannot see targets beyond 25 to 30 kilometers when the aircraft is that close to the surface. Flying this low, however, demanded constant vigilance. Every vibration forced the flight computer to adjust wing loading and thrust. Any miscalculation could result in ground impact or engine damage from foreign object ingestion. At 15:03, the F-16's afterburner ignited. The jet accelerated off the mobile runway, gear retracted, and immediately descended into a nap-of-the-earth profile. Its route had been carefully charted through clean corridors, identified by satellite imagery to avoid dust, debris, or flocks of birds that might threaten the engine. Above the border, surveillance drones rose to monitor the Russian facility, ensuring commanders were inside and the antennas were active. The plan hinged on a dangerous maneuver. To achieve the range needed for the JDAM-ERs, the aircraft would eventually have to climb sharply, a pop-up maneuver. This would expose it briefly above the radar horizon, giving Russian operators a fleeting chance to detect and engage the aircraft. For that reason, decoys and electronic warfare played a central role. At 15:18, the decoy package was activated. Miniature UAVs dispersed, transmitting intermittent false signals. Some emitted radar reflections with low radar cross-section, cluttering detection tables. Others left optical traces, further confusing visual confirmation systems. The goal was simple: delay the operator's ability to recognize the real F-16 in the seconds that mattered most. By 1521, the threat warning receiver lit up with its first alert, radar illumination from the northeast. The pilot immediately executed a beam maneuver, turning perpendicular to the radar to complicate Doppler tracking. The onboard ALQ-131 jammer broadcast broadband noise. Moments later, a missile launch warning triggered. A Russian surface-to-air missile had been fired. The pilot responded by deploying the ALE-50 towed decoy, reducing speed slightly and widening the turn radius to pull the missile off course. The tactic worked. The missile locked onto the decoy and detonated at long range, never threatening the aircraft itself. That success bought only seconds. The radar operators would quickly reacquire the target and prepare another launch. It was now or never for the pop-up maneuver. At 1522, the F-16 pulled sharply upward at a 35 to 40 degree angle, climbing to roughly 2,000 meters. This climb was essential. The JDAM-ER relies on its wing kit to glide extended distances. The higher and faster the release, the farther the bomb can travel before impact. By climbing in this window, the pilot ensured the bombs could be released from outside the most lethal envelope of Russian defenses. The bombs themselves had been prepared with delayed fuses set to 1.1 seconds. This ensured detonation would occur below the surface, inside the underground galleries rather than on the exterior concrete. Each 454-kilogram bomb combined GPS and inertial guidance, ensuring accuracy even if Russian jamming interfered with satellite signals. Once released, the wing kit would deploy, allowing the bomb to glide at a controlled angle toward its target. Seconds after reaching altitude, the pilot released both JDAMs in close sequence. The aircraft then immediately dove back down, returning to its low-altitude egress route. By reducing altitude again, the F-16 disappeared below the radar horizon, making reacquisition nearly impossible. The aircraft exited the area at treetop level, using speed and terrain masking to evade detection. Meanwhile, the JDAMs transitioned to their glide phase, wing deployment commands executed within seconds, GPS corrections synchronized, and the munitions angled downward at approximately 40 degrees toward the facility's roof block. The first bomb struck at 1527, entering within meters of the main ventilation shaft. The delayed fuse detonated deep within the gallery system. The result was catastrophic. Pressure chambers collapsed, corridors caved in, and the shockwave destroyed the internal electrical and ventilation systems. The second bomb impacted seconds later, compounding the destruction. The ground floor collapsed, dislodging support columns and shattering walls. The combined pressure cracked the structural block above, while furniture, consoles, and tactical maps inside the command room were obliterated. There was no fire, but the internal pressure was devastating. The underground complex was effectively destroyed from the inside. All 25 personnel inside, including battalion commanders, chief of staff, ammunition officers, and planners, were killed instantly or trapped beyond rescue. The strike's effectiveness was confirmed almost immediately. Ukrainian intelligence cross-referenced intercepted signals, satellite imagery, and field reports. The blast depth was measured at 3.2 meters, with a hole diameter matching JDAM-ER profiles. Internal collapse patterns aligned with delayed fuse detonation effects. Reports confirmed the presence of 2 colonels, 4 lieutenant colonels, and 3 engineering chiefs among the casualties. For Ukraine, the operational impact was decisive. With the headquarters destroyed, Russian command and control in the Kherson sector collapsed. For 8 hours, forward planning halted entirely. Artillery fire missions were delayed. Supply headquarters could not approve movements. Engineering work ceased. Drone flights were suspended. Troops at the front received no new orders and remained inactive. Transport and relocation were frozen. The disruption lasted far beyond the initial hours. For 72 hours after the strike, Russian forces struggled to restore command continuity. Backup personnel were not immediately ready. Secondary headquarters were too far away to coordinate quickly. Data had to be transferred manually, increasing delays. Communication frequencies were mixed, leading to confusion. Some artillery units received duplicate orders, while others received none. Certain batteries could not fire at all. Forward units went into standby, armored formations waited for permission to move, and reconnaissance flights were postponed. The strike demonstrated the strategic utility of the JDAM-ER. Unlike surface damage weapons, its penetrating design maximized internal destruction. The delayed fuse ensured explosions occurred where pressure and shock waves would cripple underground facilities. For defenders, the options to counter such weapons are limited. Deeper bunkers, redundant shafts, backup power systems, and stronger close-in defenses can help, but each introduces new vulnerabilities. Ventilation must connect to the surface. Fiber optics must emerge somewhere. Power must link to external sources. Each point can be analyzed, mapped, and targeted. Still, the operation also highlighted risks. Success depended on favorable conditions: wind, accurate digital terrain models, reliable GPS signals, and functioning UAV surveillance. Any disruption, a faulty fuse, poor weather, or lost tracking, could have caused the attack to fail. That is why Ukraine synchronized decoys, jamming, and multiple intelligence sources to reduce the risk of failure. The broader consequences extended beyond the physical damage. Russian headquarters discipline shifted noticeably after the strike. Command posts were relocated deeper underground and farther from the front. Decision-making slowed. Officers reduced field visits, preferring remote communication. Concealment became a priority, lengthening communication times and reducing responsiveness. The psychological impact of knowing that a single aircraft and 2 bombs could eliminate an entire command node in minutes was significant. For Ukraine, the mission became a template. The F-16, operating from mobile bases, had flown a 20-minute mission, released 2 munitions, and returned without detection. Post-strike, the Ukrainian Air Force refined procedures. The number of mobile bases was increased. Fuel supply lines were duplicated for redundancy. Pod systems received software updates to accelerate data transfer. Mission computers were optimized to shorten targeting cycles. Pilot training incorporated new tactical scenarios. Radar suppression timing was extended. Targeting systems were further synchronized. Fuse sensitivity and accuracy were improved. The result was a mission model now considered standard: rapid deployment from mobile bases, precision strikes with JDAM-ERs, and immediate relocation of aircraft to minimize vulnerability. This single strike demonstrated that a carefully planned operation, executed with precision weapons, could paralyze an entire sector of Russian operations. It showed that Ukrainian air power, though limited in scale, could generate outsized effects when paired with intelligence-driven targeting and Western-supplied munitions. In summary, the destruction of the Kherson underground headquarters on August 10th was more than a tactical success. It severed command links, disrupted operations for days, eliminated senior officers, and forced systemic changes in Russian command practices. The strike highlighted the vulnerabilities of underground facilities, the precision of JDAM-ER munitions, and the effectiveness of mobile F-16 operations. It also underscored a broader truth. In modern warfare, the combination of intelligence, timing, and precision-guided weapons can achieve strategic results disproportionate to the scale of the mission.